Hello friends, in today's class we are going to see about the design process of embedded system. So how to design our embedded system? So what are all the steps involved to design our embedded system? That's what we are going to see in our today's class. So the steps involved to design the embedded systems are the requirement, specification, architecture, components and system integration. There are two approaches to design our process. One is top-down methodology. The another one is bottom-up design. So here the bottom-up design means work from small components to big system. In top-down design, we will start our design with most abstract description to conclude with the concrete details. That is the top-down methodology. And here our major goals of the design is manufacturing cost, performance, power consumption. This PPM rule we have to always keep in our mind. That is power consumption, performance and manufacturing cost. Here the performance stands for both overall speed as well as the deadline. So this deadline is very important in embedded system because it is dedicated for the specific tasks as well as it has to complete the task within a allotted time period. That is very important. So in each step of the design we have to do three things. One is analyze, another one is refine and verify. Why we need to analyze? We have to analyze each step of the design in order to determine how we can meet the specifications. Then we have to refine the design every time in order to add the details to get the specification. And we must verify the design to ensure that it still meets the system goals such that cost, speed as well as the performance. So first let us see about the requirement. So the requirement is nothing but the informal description gathered from the customers and refine the requirement into specification that contains enough information to begin designing the system architecture and requirements. The plain language description of what the user wants and expects to get may be developed in several ways. It can be talking directly to the customer or talking to the marketing representative, providing a prototype to user for the commands. So requirement may be a functional requirement or non-functional requirement. So we must capture the basic functions of the embedded system, but functional description is often not sufficient. Typical non-functional requirements include the performance, cost, as well as the physical size and weight and power consumption. Here, the performance stands for the speed of the system. It is often the major consideration for the usability of the system and for its ultimate cost, because if once we increase the speed of the system means ultimately it is directly proportional to our cost. Speed of the system if we are increasing means we are increasing the processor speed. We are going for the upgraded version of the processor, which means that the cost is intended to be a increased one. Okay, then coming to the cost, the cost is the purchase price for the system. It does always we have to include for the consideration in the non-functional requirement. So there are two major components in the cost. One is the manufacturing cost, which include the cost of the component as well as the assembly cost. The another one is non-recurring engineering cost, which include the personal and other cost of the designing the system. Then third one is the physical size and weight. The physical aspect of the final system can vary greatly depending on the application. An industrial control system for an assembly line may be designed to fit into the standard size rack with the no strict limitation on a weight. A handheld device typically has a tight requirements on both size and weight that can ripple through the entire system design. Finally, the power consumption. The power is the importer in battery powered system, and it is often important in other application as well. The power can be specified in requirement stage in terms of the battery life. The customer is unlikely to able to describe the allowable voltage. So these are the some of the non-functional model of the. So this is the sample requirement form. So this sample requirement form consists of a name, purpose, inputs, outputs, functions, performance, manufacturing cost, power, physical size and weight. It can be filled out at the start of the project. So we can use this form as a checklist in the considering the basic characteristics of the system. So let us consider the entries in the form. The first one is name of the system. So we are name of the project. The next one is purpose. This should be a brief one or two line description of what the system is supposed to do. Then the inputs and outputs. So the inputs and outputs to the system comprises a detail of what types of data we are going to use, what is the data characteristics, and what types of input devices and output devices we are going to use. So here the types of data means analog or digital data, whether we are going to give mechanical input or some electronic signal, that is analog signal we are going to give, that we need to specify in the input session, and we have to represent the data characteristics, whether we are going to arrive our data periodically, such as it can be a digital audio sample, or occasionally we can get the input signal. So if we are getting occasionally, how many bits we are going to get, how many how long, on which period we are going to get, that also we need to specify. Then the type of input output device we have to represent, whether we are going to use the analog or digital buttons, or it can be a video output or audio output, or whether we need to use the analog to digital converter at the output. So that also we need to specify in the input output. Then functions. This is the more detailed description of what the system does. Uh, when the system receive an input, what does it do? How do user interface input affect these function, and how do different function can be interacted? That we have to specify in the function in. Then power. Many embedded computing systems spend at least some time controlling a physical device or processing the data coming from the real world. In most of these cases, the computation must be performed within a certain time frame. So it is essential to mention the speed as well as the deadline of the system performance in the sample requirement form. Then coming to the manufacturing costs. This cost primarily include hardware as well as the software component costs. So if we don't know the how much cost exactly the product is also, but we should have some rough idea about the cost of the system. According to that only we need to choose the processor, then power consumption, whether it is a battery backup device or what, that we have to decide, depends on the manufacturing cost only. So it is the very important parameter in the sample requirement form. Then coming to the power. So we have to decide while filling the sample requirement form itself, whether our device is a battery backup device or plugged into the wall. So if the battery powered machine means it has to use the energy should be carefully. So frequently battery powered devices will be a failure model. Then coming to the physical size and weight. So you should give some indication of the physical size of the system to help certain for certain architectural decision. A desktop machine has much more flexibility in the components used than, for example, laptop. So next one we are going for the application of the embedded design process. That means we are going to design our GPS moving map, that is global positioning system. So what is the function of global positioning system? It has to identify where we are standing. So it has to accurately tell the location where we are locating or where we are standing. Depends on the latitude or longitude position. Here the functionality of the global positioning system. So the system should show the major routes and other landmark which is available in standard topographic database. So the system is designed for highway driving and for similar uses. So here it has to position the object, or it has to position the vehicle, or it has to position the human. So the user interface could be a uh, 400 cross 600 pixel resolution. The device should be controlled by no more than 3 buttons. The menu system should be pop up on the screen and the buttons are pressed to allow the user to make selection to control the system. Here the performance, that is speed and deadline. The system has to be updated within every 15 seconds and the cost of the system should not exceed more than $100. The physical size and weight of the system should not go beyond the palm of the hand. So it should be handy in size. The device should run for at least 8 hours or on a 4 AA batteries. So this is the sample requirement form of the GPS moving system. So here name of the system is GPS moving map and the purpose of the system is moving map for the driving use, and the input for the system is to control buttons which is used to move up and downwards and power button. The output should be indicated in the LCD display that could be in the size of 400 to 600 pixel. The main function of the system is it always display the current latitude and longitude of the object, and the performance every 0.25 seconds it has to update the system, depends on the moment. So the manufacturing cost should not exceed uh, $30, and the power is it should consume only 100 milliwatts, and the physical size is not more than 12 ounces. So the remaining design process steps we will see in the second part of the video. Thank you.